This tutorial explains how to supply the required information for the automated checks and how to run them. QA for LiDAR is designed to step through the items in the left menu panel in order. After a project has been opened and the user and project settings completed, you can move to the automated checks. Only one user can run the automated checks at a time for a project. Certain control network and processing information needs to be provided for the automated checks. There are 4 survey control point types that can be input as shapefiles. The LiDAR provider fundamental vertical accuracy or FVA checkpoints are part of the independent checkpoint network and are used to assess the fundamental vertical accuracy of the survey. They must be gathered internal to the project area and are often collected in clusters on open flat ground where there is a high probability the sensor will have detected the ground surface for easy comparison to LiDAR ground points. In QA for LiDAR, they are used as part of the survey control collection method, density, and distribution checks, as well as the flatness, openness, and absolute vertical accuracy checks. To add a survey control point shapefile of any type, click the button beside the relevant type and open the shapefile. Use the elevation field AHD drop-down list to select the field type in each shapefile which represents AHD elevations of the points. Do the same for the elevation field ellipsoid if applicable. Finally, use the drop-down list to select the acceptability rating you wish to use for the control points. This rating is used in the flatness and openness part of the accuracy of survey control check and the absolute vertical accuracy check. If the rating for flatness or openness is unacceptable based on your acceptability rating for a checkpoint, that point is not used to test the accuracy of the survey control or the absolute vertical accuracy of the data. Both flatness and openness for a control point must be rated equal to or better than the user's acceptability rating for the point to be used. The lower the rating selected, i.e. the closer to poor, the more control points that will be used for that type. Some testing of your control may be required, i.e. you may want to start with a rating of poor to run the accuracy of survey control or absolute vertical accuracy check, then examine the output control files for the flatness and openness rating results for each point and try changing the rating to suit your requirements. The LiDAR provider ground control is the next type. Along with GPS base station data, GC make up what is termed the control network. GC are high accuracy points, e.g. state benchmarks, that are used by the provider to establish the datum in the survey area and adjust the LiDAR horizontally or vertically. They can be internal or external to the project and assess the variation of the reference surface and geoid model across the survey area. In QA for LiDAR, they are used for the survey control collection method, density and distribution checks, as well as for flatness, openness, and absolute vertical accuracy checks. The contracting agency custom control is next. This can be any other control or shapefile elevation data of known accuracy that the purchaser has access to. It will be used by QA for LiDAR for the survey control density and distribution checks and the flatness, openness, and absolute vertical accuracy checks. It should overlap with the survey area. To add additional custom control, click the green plus button. Finally, there is the LiDAR provider supplemental vertical accuracy checkpoints, or SVA checkpoints. These are part of the independent checkpoint network and are used to assess the supplemental vertical accuracy of the survey. They must be gathered internal to the project area and are located in a range of different terrain types. In QA for LiDAR, they are only used as part of the absolute vertical accuracy check. For SVA CPs, instead of the acceptability rating, the final drop-down box is for cover type field. After selecting the elevation fields, ellipsoid isn't relevant in this case, select the field in your SVA checkpoint shapefile that represents the land cover type to which each point is associated. E.g., you might have a field called class with attributes such as tree, grass, etc. To add a flightline shapefile, click the button beside the box and open the shapefile. Use the point source ID field to select the field in the shapefile that represents the flight line number as per the point source ID attribute in the LAS files. The flight line shapefile is used for SWAT related checks. This dataset does not have a flight line shapefile. The raster cell size will be used to produce output rasters for the density checks as well as for data processing during the relative vertical accuracy check. If a cell size greater than 5 meters is selected, the relative vertical accuracy check will not run. Use the slider bar to select the cell size you wish to use. The default and minimum cell size is 2 meters, while the maximum is 50, which is intended for bathymetry LiDAR data coverage assessments. The checks are organized into groups. The tick boxes can be used to select which automated check groups or individual checks you wish to run. The checks are listed in the order it is suggested they be run in. When a new project is opened, the delivery completeness and spatial file corruption check is the only one ticked. It is highly recommended that this check group be run first without ticking any of the following check groups. If the delivery is incomplete or corrupt, it is likely subsequent checks will fail and significant time may be wasted running them. Hence, if any part of this check group fails, this will halt the QA session so that if you had more checks queued to run, they will not run until the failure issue is addressed. It is more efficient to update or fix any delivery incompleteness or corruption in the data before running the other checks. One exception to running this check first is if you only wish to run the accuracy of survey control check to validate the proposed survey control in the planning stage of the project. After running the checks in the delivery completeness and spatial file corruption successfully, it is a good idea to run both the file naming, shapefile attributes and horizontal coordinate system, and comparison of tender and report form checks before queuing the remaining checks to run. If you are working with a large dataset, the remaining checks can be run over the weekend. If, for example, there is a significant LAS or DEM file naming issue, many of the remaining checks may be unable to run before this issue is addressed. It would be unfortunate if you had set all the remaining checks to run over the weekend, but on return found they were unable to successfully run due to an issue such as file naming. When the first 3 checks have run successfully, the remaining checks can be queued to run, i.e. classification statistics, accuracy of survey control, point density and DEM resolution, flight line coverage, and absolute and relative vertical accuracy. You may also select to prepare visual checks, which will produce the DEM mosaic for the project. Again, if you are working with a large dataset, it may be wise to do this over the weekend as it may take some time. When the Run button is clicked, the Automated Checks QA session running screen will appear and processing for the checks will begin. For explanation of the methods used in the checks, please refer to the user manual. Thank you for watching this QA for LiDAR tutorial. For further tutorials, please visit the QA for LiDAR YouTube channel.